Hello everyone, welcome back to my YouTube channel. Now I am going to discuss about the subject civil engineering. Let me introduce myself. I am Nishchita SN, Department of ECE, 2nd SEM BE in Sri Venkateshwara College of Engineering, Bangalore. First, we know about what is civil engineering. Civil engineering is a branch of engineering that deals with the design, construction, and maintenance of built environment. It involves the planning, designing, and implementation of various infrastructure projects. Civil engineers plays a crucial role in shaping the physical environment and improving the quality of life. There are nine scopes of civil engineering. First one surveying, structural engineering, geotechnical engineering, hydraulics and water resources, transportation engineering, environmental engineering, construction planning and project management, earthquake engineering, remote sensing and GIS. Now we know briefly about the surveying. We think about the surveying, it mainly deals with measurement or plotting of plans like that. To start any development activity in an area, the relative position of various objects in the horizontal and vertical direction are required. This is achieved by the surveying the area. Unless maps are drawn, no development work and construction can be undertaken. Earlier, conventional instruments used for surveying like chain, tape, leveling instruments, etc. Modern instruments are distance meter, total station, theodolite, etc. Modern technology or photogrammetry and remote sensing have surveying easier. Next one is structural engineering. Structural engineering is a type of the civil engineering. When we design of buildings, bridges and other infrastructure, structural engineering is the main role. Then they analyze and calculate the loads and forces that structure will be encountered to ensure their stability. Civil engineers use computer aided design software to create detailed structural plans. Next one is geotechnical engineering. Geotechnical engineering is also an essential part of the civil engineering. It mainly deals with the behavior of soil and rocks. Civil engineers assess the suitability of the soil for construction projects and design foundation accordingly. They conduct soil testing and analysis to determine its properties and stability. Hydrolysis and water resources. As we know that water is a very important need for all human beings. It mainly deals with the study of mechanics of water and its flows characteristics like pipe flows, open channel flows, dams, irrigation and hydropower, etc. Civil engineers plays a significant role in the management and conservation of water resources. They design and construct dams, reservoirs, and water supply systems. Civil engineers also work on wastewater treatment plants and flood management systems. Transportation engineering. Civil engineers are involved in the planning and design of transportation systems like roads, railways, and airports, etc. They analyze traffic patterns and develop efficient transportation networks. Civil engineers also work on improving transportation safety and reducing congestion. Next one is environmental engineering. Environmental engineering is a crucial aspect of civil engineering that focuses on protecting and preserving the environment. Civil engineers work on projects related to waste management, air and water pollution control, and sustainable development. They develop strategies to minimize the environmental impact of construction projects. Construction planning and project management. This is also like structural engineering. It deals with the different types of construction of structures like buildings, roads, bridges, etc. Earlier days, only manpower is utilized for construction, but development of new technology, that is, manufacture of new machineries like cranes to lift weight, painting machines, plastering machines, concrete or tar laying machines, have made the construction easy and faster. It mainly includes excavation of soil, construction of foundation, concreting, finishing, etc. With different techniques and methods. Civil engineers often take on project management roles of overseeing various aspects of construction projects. They develop project plans, manage budgets and water resource and ensure timely completion. Earthquake engineering. An earthquake is a sudden and rapid shaking of the ground due to passage of vibration beneath caused by transient disturbance of elastic or gravitational equilibrium of rocks. The scientific study of earthquake is called seismology. Earthquakes are measured using observation from seismometer. Seismic waves are recorded on instruments called seismographs. The time, location, and magnitude of an earthquake can be determined from the data recorded by seismograph stations. Earthquakes with magnitude of about 2 or less are usually called micro earthquakes are generally recorded only on local seismographs. Last one is remote sensing and GIS. This is one of the new fields. The improvement in space technology availability of GPS enhances the scope of geographic information system. Good mapping technique helps to get required information accurately and quickly to effectively manage and monitor the available resource for optimal use. GIS is an high-tech equivalent of map. It represents a means to locate overseas in relation to world around us. It deals with measurement mapping, monitoring and modeling of geographic information around us. Next, we know what are the materials used for construction. Bricks, cement and mortars, plain concrete, reinforced and pre-stressed concrete, structural steel, construction chemical. We know briefly about this. First one is bricks. We know commonly bricks are used for construction. How bricks are obtained? These bricks are obtained by molding clay in rectangular blocks of uniform size and then by drying and burning these blocks. They offer strength, durability and thermal insulation. As bricks are of uniform size, they can be properly arranged, light in weight and hence bricks replace stones. Bricks can be mainly divided into two types. Unburnt are also known as sun-dried bricks. Burnt bricks. Unburnt bricks can only be used in the construction of temporary and cheap structures. Such bricks should not be used at places exposed to heavy rains. Next one is burnt bricks. These bricks are used in construction works. These bricks are commonly divided into three types: first class bricks, second class bricks, third class bricks. First class bricks. These bricks are plain surface, sharp edges and size with tolerance in dimension plus or minus 3%. These bricks are uniform red or brownish colored. They have high crushing strength not less than 10.7 Newton per millimeter square. These bricks are machine molded, efflorescence is zero, water absorption is less than 15%. These bricks are mainly used for the exterior wall bricks work, short columns and arches. Next one is second class bricks. These bricks are slightly uneven faces and edges with tolerance in dimension plus or minus 8%. Uniform colored but may be slightly overburnt and they have high crushing strength not less than 7 Newton per millimeter square. These bricks are hand molded, efflorescence is little, water absorption is less than 20%. These bricks are used for internal walls and compound walls. Last type of bricks is third class bricks. These bricks may be distorted with blunt edges, overburnt or underburnt and non-uniform color. High crushing strength not less than 3.5 Newton per millimeter square. These bricks are hand molded, efflorescence is large, water absorption is less than 25%. These bricks are used for flooring, paving, small brick foundation and brick pad lime concrete. Next material is cement. We know cement is a crucial building material used in construction projects worldwide. Different types of cement are available to suit various applications and requirements. Understanding the type of cement is essential for selecting the right one for your projects. This cement can be divided into three types. First one is ordinary Portland cement, is also known as OPC. OPC is the most commonly used cement worldwide. It is suitable for general construction purposes. OPC is available in three grades: 33, 43 and 53. These grades are indicating their compressive strength. Second one is Portland Pozzolano cement. This one is PPC. PPC is manufactured by blending OPC with pozzolanic materials like fly ash or volcanic ash. It enhances workability, reduces heat of hydration, and improves durability. PPC is widely used in hydraulic structures, marine construction, and mass concrete works. Last type of cement is Portland slag cement. Portland slag cement is the type of the Portland cement obtained by mixing Portland cement clinker and gypsum with granulated blast furnace slag in suitable proportions and grinding them into a thorough and intimate mixture. The Portland slag cement can also be manufactured by separately grinding Portland cement clinker with gypsum and blast furnace slag, then later mixing them both thoroughly suitable proportions. Next material is mortar. Mortar is the mixture of cement, sand and water. Uses of mortar are: mortar is used between the joints of the bricks during the construction of walls. It is used to give a soft, even bed between different layers of bricks or stone masonry for equal distribution of pressure over the bed. It is used in plastering works to hide the joints and to improve appearance. Used in the manufacture of precast pipes, plant pots, and precast water tanks. Used for repair of cracks. It is used for molding and ornamental purpose. There are 9 types of mortar. First one is lime mortar, gauge mortar, sudki mortar, cement mortar, lime pozzolano mortar, mud mortar, aerated cement mortar, heavyweight mortar, lightweight mortar. Next material is concrete. Concrete is obtained by mixing cement, fine aggregate, coarse aggregate and water in a definite proportion. This concrete is commonly divided into three types: plain cement concrete, reinforced cement concrete, pre-stressed cement concrete. First one is plain cement concrete, is also known as PCC. This is used for construction material composed of cement, fine aggregates and coarse aggregates mixed with water which hardens with time. This plain cement concrete is divided into 6 types: normal strength concrete, lightweight concrete, high density concrete, air entrained concrete, high strength concrete, high performance concrete. Second one is reinforced cement concrete, is also known as RCC. Concrete has very high compressive strength but low in tensile strength. Wherever tensile force are involved like in slabs and beams, it is recommended not to use plain concrete. So adding steel to the concrete is the solution, as we know it has high tensile strength and also possesses good compressive strength. However, the bond between the concrete and steel works well, and when these two are combined called reinforced cement. After the alliance, the material is known as reinforced cement concrete. The last one is pre-stressed concrete, is also known as PSC. Pre-stressed concrete is a system devised to provide sufficient pre-compression in the concrete beam by tensioned steel wires, cables or rods that under working condition that concrete has no tensile stresses are also so low that no visible cracking occurs. This can be divided into two types: pre-tensioning, post-tensioning. Next one material is steel. Steel is an alloy of iron and carbon containing carbon from 0.25 to 1.25%. Steel is highly elastic, ductile, malleable, forgeable and weldable. This steel is divided into three types: mild steel, tough steel, high tensile steel. First one is mild steel. Mild steel is a plain carbon steel. The percentage of carbon alloy is less than 0.25%. It is used as a structural as well as non-structural steel in form of various sections like first section, channel, angle and in form of round bars as the reinforced cement is in concrete. Mild steel bars are designated as iron 250 where 250 is yield strength in Newton per millimeter square. Iron denotes the ferrous metal. Next one is TMT or TOR steel. Thermomechanically treated or TMT bars are high strength reinforced cement bars that features a dough outer core and a soft inner core. To put it simply, it is a form of HYSD steel where the steel bars after undergoing the mandatory heat treatment process. Next one is high tensile steel wires. Two wires are spun together to form the strand. A group of strands or wires are placed together to form a pre-stressing tendon. A group of tendons form a pre-stressing cable. Their ultimate strength range from 1500 to 2350 Newton per millimeter square. Last material is construction chemicals. First one is adhesives. Adhesives have rich bonding properties apart from weatherproofing and waterproofing. They are widely used in all types of construction works which include panel fixing, tile fixing and floor covering. Second one is sealants and chalks. Sealants and chalks are construction chemicals that are used to block an opening surface or small cracks to prevent liquid or gas or moisture leakage that can damage the construction. Third one is epoxy grouts. These chemicals are used for grounding and as high durability property and can be even in extremely high temperature. These chemicals are quite expensive. Fourth one is add mixtures. Add mixtures are used to modify the flow characteristic strength and durability. Last topic is structural elements of a building. There are 9 structural elements of a building. First one is foundation, plinth, lintel, chajja, masonry wall, column, beam, slab, staircase. First one is foundation. We know foundation is the main part of the building construction. A foundation is the lowest part of the building structure resting on soil or below ground level. This foundation can be divided into two types. First one is shallow foundation. This shallow foundation can be divided into four types: individual footing or isolated footing, combined footing, strip foundation, raft or mat foundation. Second one is deep foundation. This deep foundation they can be divided into two types: pile foundation, drilled shaft or cajon. Second one is plinth. The plinth is a part of the foundation constructed either at or above the ground. Plinth is the offset created between the ground level and the superstructure of the building. It is made by construction of bricks or stone wall or RCC beam from the ground level to the flooring level of the building. Plinth constructed by RCC beam is called a plinth beam. Third one is lintel. Lintel are constructed above the wall opening like doors, windows, etc. Its main function is to support the weight of the wall coming over the opening. Types of lintel are timber lintel, stone lintel, reinforced brick lintel, steel lintel, RCC lintel. Fourth one is sajja. This is the structure that is generally constructed above the window and projected outside from the window face. Sajjas can also be provided above doors. Sajjas are constructed from reinforced cement concrete. Fifth one is masonry walls. Walls are vertical elements of a building which support the roof. They provide an enclosure and protect against wind, sunshine, rain, etc. Doors and windows opening are provided in the walls for ventilation and access to the building. It can be constructed using stone, bricks, concrete blocks, etc. Different types of bonds are used for constructing walls. The main function of masonry wall is to provide an enclosure and protect against wind, sunshine, rain, etc. Next one is columns. Columns are vertical members constructed above the ground level to support any structural frame. Load coming from the slab and beams are transferred to the columns and columns transfer to the load to the footing safely. Types of columns are rectangular or square columns. Second one is circular columns. Third one is short columns, long columns, axial loaded columns, column with uniaxial eccentric loading. Seventh one is column with biaxial eccentric loading. Eighth one is composite columns. Seventh one is beams. Beams is a horizontal structure member used to carry vertical load, shear load and sometimes horizontal load. It is the major component of building structure. It mainly used in construction of bridges, trusses and other structure which carry vertical load. Types of beams based on geometry they can be divided into three types: straight beam, curved beam, tapered beam. Next one is based on material: timber beam, reinforced concrete beam, steel beam. Next one is based on cross section: rectangular beam, T beam, high beam. Next last one is based on type of support: simply supported beam, fixed beam, continuous beam, cantilever beam, overhanging beam. Eighth one is slabs. Slabs are constructed to provide flat structure, usually horizontal in building floors, roofs, bridges and other types of structures. The slab may be supported by walls or by reinforced cement concrete beams, usually cast monolithically with the slab or by structural steel beams or by columns or by the ground. Types of slabs are one-way slabs, two-way slab, flat slab, grid slab, precast slab, composite slab, hollow core slab, sunken slab, facet slab, projected slab. Last one is staircase. A stair is a sequence of steps that connects different floors in building structure. The space occupied by a stair is called as the stairway. Stairs can be constructed by wood, steel, bricks or stone, RCC, etc. Its main function is to provide an access from one floor to another, to provide a safe means of travel between floors, to provide a suitable means of escape in case of fire. Types of stairs are straight stair, dog-leg stair, open navel stair, circular stair, spiral stair, bifurcated stair. Thank you for watching my video. Please like me my video.